Hello grade 8 learner! Welcome to another video lesson in mathematics. In this video lesson, we will be discussing how to multiply rational algebraic expressions. It's another great day to learn, so grab your pen, paper, and module as you start watching and learning from this video lesson. Happy learning! This lesson is based on the K-12 curriculum learning competency. The learner performs operations on rational algebraic expressions. By the end of this lesson, you, the learner, should be able to follow the steps in multiplying rational algebraic expressions, apply appropriate factoring techniques while multiplying RAEs, and to apply the process on given rational algebraic expressions. We begin the lesson by reviewing how to multiply fractions. In multiplying fractions, what we do is to multiply the numerators and the denominators together. In the given example, to multiply 2/3 with 5/7, we multiply 2 and 5 together and 3 and 7 together to get the product, which is 10/21. If the fractions have common factors, especially between the numerator of the first fraction and the denominator of the second fraction, and the denominator of the first fraction and the numerator of the second fraction, then we can first cancel out these common factors, then multiply the remaining numbers. Here, we observe that 12 and 15 have a common factor, which is 3, so we factor that out. We also see that 4 and 8 have a common factor, which is 4, so we also factor that out. From our resulting expressions, we see common factors that we can cancel out. First, 3 from the factors of 12 and the factors of 15, then 4 from the factors of 4 and 8. We can also see that from the first fraction, 4 and 2 have a common factor, which is 2, so we cancel that out, leaving 2 in the numerator and 1 in the denominator. After canceling out the common factors, we multiply the remaining fractions, which are 2/1 and 1/5, to get the final product, which is 2/5. Those are the two possible methods we can use in multiplying fractions. Now, how does this relate to multiplying RAEs? To multiply rational algebraic expressions, we follow this formula. A over B times C over D is equal to A times C over B times D, which is equivalent to the product of AC over the product of BD, provided that A, B, C, and D are polynomial expressions and that B and D are not equal to 0. We have the following example to emphasize that. If you observe, multiplying RAE is just like multiplying fractions because, as we have said in the previous lesson, RAEs are fractions. To do operations on RAE is similar to doing operations on fractions. Let's study an example. We are going to find the product of 15a squared over 8ab cubed c and 4c over 5ab. To solve this, we first write the numerator and denominator in their factored forms. We have to check each expression for any common factors. We then see that we have the factors of 15a squared and 5ab with 5a as a common factor. We also have the factors of 8ab cubed c and 4c, with 4c as a common factor. Also, we observe that in the first fraction, a is a common factor, so we factor that out as well. After factoring out the expressions, we now cancel out the common factors between the numerators and denominators. Remember the process we followed when we canceled out common factors. We begin by canceling out the common factor between the numerator of the first RAE and the denominator of the second RAE, which is 5a. Then, we cancel out the common factor between the denominator of the first RAE and the numerator of the second RAE, which is 4c. Finally, we check if there are common factors within the same expression, and we see that in the first expression, there is a common factor. So we cancel out a. Now that we've canceled out the common factors in the RAEs, we multiply the remaining expressions. What are the remaining expressions that we have? In the first RAE, we have canceled out 5a and a, which left 3 in the numerator. In the denominator, we canceled out 4c and a, leaving 2b cubed. Thus, the remaining expression is 3 over 2b cubed. For the second RAE, we canceled out 4c, which leaves 1 in the numerator. Take note, if you cancel out a factor like 4c, the numerator does not disappear because 1 remains as a constant factor to expressions. For the denominator, after canceling out 5a, what remains is b. Thus, the second RAE remaining is 1 over b. If we multiply 3 over 2b cubed and 1 over b, the final product will be 3 over 2b raised to 4. Another way to solve this problem is by simply multiplying the numerators and denominators together. But doing that gives us expressions with larger numbers and variables with high exponents. Eventually, we have to simplify our answers by factoring out the expressions and canceling out common factors, which still leads us to the same answer as we got in the previous method. You may choose what method you want because both methods will give you the same answer if done properly. But you have to think carefully about what is more convenient or easier for you to do, especially with polynomial expressions like the next example. In this example, we are going to solve for the product of a squared plus 2a minus 8 over 3a and negative 12a squared over a plus 4. As we have said before, you can multiply the numerators and denominators together to get the product, but writing the numerators and denominators in their factored forms first will help identify common factors quickly and simplify the final product easier, especially that we have polynomial expressions. Thus, for this problem, we have the following factors for the RAEs that we are multiplying. Observe that because a squared plus 2a minus 8 is a trinomial, we use the method for factoring quadratic trinomials to get its factors. For negative 12a squared, we use common monomial factoring. take note of the similar factors. The next step is to cancel out common factors. We begin by checking and canceling out common factors between the numerator of the first RAE and the denominator of the second RAE, which is the binomial a plus 4. Then we check the common factors between the denominator of the first RAE and the numerator of the second RAE, which is 3a. Lastly, we check if there are common factors within the same expressions, but we find that there are none. So we move to the final step in the process. We multiply the remaining expressions. First, let's check out what expressions remained in each RAE. In the first RAE, we canceled out a plus 4 in the numerator and 3a in the denominator. So that leaves us with the expression a minus 2 over 1. For the second RAE, we canceled out 3a in the numerator and a plus 4 in the denominator, which leaves us with negative 4a over 1. We then multiply the remaining expressions. We get the product of the numerators by applying the distributive property on the monomial negative 4a and the binomial a minus 2. For the denominators, we see that what remains is 1, and if we multiply 1 by 1, we get 1. When we do the operation properly, we end up with the final product, which is negative 4a squared plus 8a. Good job for following the lesson! If there are some things which are still not clear to you, you can rewind the video, read your module, or ask help from your teacher to improve your learning. To practice what you've learned, try solving this problem. What is the product of x squared plus x minus 6 over 4x squared minus 2x multiplied by 2x minus 1 over x minus 2? Pause this video and solve before we move to the answer. Done? If your answer is x plus 3 over 2x, you are correct. Good job! If you didn't get the correct answer, check out the solution to see where you went wrong. Congratulations for finishing this video lesson. Learning is never an easy process, but if you keep working at it, eventually it will come easy to you. As the American blues musician B.B. King said, the beautiful thing about learning is that nobody can take it away from you. Keep on learning, dear learner, and we'll see you again in our next video module.